So in this lesson, we're going to put together some of the information that we've been doing over the last several lessons. We're going to talk about how to graph the function given the derivative first. And so given the derivative graph, they want us to find these things. And so intervals of increase and decrease, those and relative extrema, which would be our relative maxes and mins, those are going to come pretty easy. I'm going to go ahead and make this a two-dimensional number line, since that's what we're used to looking at to determine our intervals of increase and decrease. And so we can see that it's positive until we get to -2, and then this graph is negative for the remainder of the time, but it does go back up to 0 at 0, so we have to make a little break there. And so that means that our graph is increasing. The original graph is increasing, decreasing, decreasing. And when we go from increase to decrease, that means that we have a relative maximum. So we can go ahead and fill out these first few things. Intervals of increase, we've got -infinity to -2. And for decrease, we've got -2 to 0 and 0 to infinity. And then we have our relative maximum at x equals -2. All right, then for concavity, we need our second derivative. And so I'm going to make a second derivative number line as well. And on this second derivative number line, we're going to be looking at this and trying to determine the derivative of this graph, because this one is our first derivative. So it looks like our slopes are negative to begin with, negative slopes, then positive slopes, then negative slopes. So negative until I get to -1, then positive until I get to 0, and then negative again. And so our second derivative gives us concavity, so this means that we're concave down, then concave up, then concave down on the original function graph. So now we can fill out our concavity. So for concavity, we are concave up from -1 to, oh, I forgot to put the number on there, -1 to 0. And then concave down from -infinity to -1, and from 0 to infinity. Now, since the second derivative changes sign at both -1 and 0, we have 2 points of inflection at x equals -1 and x equals 0. All right, then they also want us to sketch the graph of this function, and it says that the zeros are at -4 and 0. So they're giving us some points that we need to use while we're talking about our sketch. So I'm going to go ahead and put those on there. And then it says that our graph increases until we get to -2. So we're going to be going up until we get to -2. Then the rest of this graph decreases. Now for concavity, our graph is concave down until I get to -1, and then it changes to concave up. So I know that somewhere in here we've got a change in concavity. So I'm going to draw this portion concave down, and then it says from -1 to 0 it's concave up. So concave up, come like this. I should have made that a little more distinct, but concave down, concave up, and then we're concave down again, but also decreasing, so it's got to keep going down. So it looks like it has kind of a cube function look to it here, which would make this a fourth power function graph, which would make sense since the derivative graph was a third power function graph. In our second example, they're giving us a graph of the function and asking us to determine all of this information, determine determining the information should be pretty easy because we're looking at the graph. So we're just trying to look at the graph and determine where it's going up. And so it looks like it's going up from negative infinity until we get to negative 3. So negative infinity to negative 3. Also increasing from this point, which is at positive 1, to 3.5. And then decreasing, going down from negative 3 until we get to this point at 1. And then decreasing again from 3.5 to infinity. All right, for relative extrema, we are looking for our relative maxes and mins. So it looks like there is a relative max here at x equals negative 3. And over here at x equals 3.5. And it looks like a relative minimum here at 1. All right, for concavity, looks like they showed us the points of inflection here, and so it looks like it's concave down from negative infinity until I get to negative 1. Then we're concave up from negative 1 to this point, which looks like it's at 2.5. And then concave down again from 2.5 to the end of the graph, infinity. All right, so we have a couple of points of inflection. Those were marked for us. So point of inflection at x equals negative 1 and at x equals 2.5. All right, so they want us to sketch the graphs of our first derivative and our second derivative. And again, I think that it might be easier to sketch it if we go ahead and put things on the number lines. So I'm going to make a first derivative number line using the information that we just collected. And so we can see that we have relative maxes and mins at negative 3, 1, and 3.5. And I know that the graph was increasing or positive from negative infinity to negative 3. And then from negative 3 to 1, it was decreasing, so negative. From 1 to 3.5, increasing again, so positive. And from 3.5 to infinity, decreasing, so negative again. So that means that when I sketch the graph of my derivative function, I need it to show all of these things. So we're going to go ahead and put some points for us to work with on our graph that we're given down here. I think I can get both of those in the picture at the same time. So we know that we want to stay above the x-axis until I get to the left of negative 3. And then we're going to be below until we get to positive 1, so below down here, and then above again until I get to 3.5, and then it'll go below again. Now, we also have some points of inflection, which mean that the second derivative is going to be 0 at negative 1, and I'm going to make that kind of small. And then again over here at 2.5. So when we're making our graph, just keep that in mind, that that means that that needs to be our maximum or our minimum in that section of the graph. And so since I know it's got to start positive and go negative, then right in here is where that's going to come down to the low point. And then we know that it comes back up and crosses at 1. And here, it's all positive until I get to 3.5. But right in here is where I would have that horizontal tangent, because I know that my second derivative of those 2 points is going to be 0. All right, then I'm also going to use the information up here to make a second derivative number line. So we know that, let's see, we have -1 and 2.5. And it's concave down, so negative, concave up, positive, concave down, negative. And so I need the graph to be below the x-axis, above the x-axis, below the x-axis. So down here, let's see if I can get that number line. Yep. We've got -1 and 2.5, and I'm going to start below, go above, and then go back below. So it's just going to look kind of like a parabola. All right, negative, positive, negative. So hopefully, whether you are given the parent function graph and ask about the derivative or the second derivative, or given the derivative graph, ask about the original function, we can use our information to make our sketches and find the missing information.